Mars. A barren wasteland, frozen in time. Or is it? They say there's no life on Mars, but what are these strange, crawling shapes? Prepare to have your mind blown as we reveal the truth behind the Martian spider invasion. That isn't actually an invasion at all. We've all seen the iconic images of Mars, the rusty red landscape, the rovers exploring the dusty plains. But what if Mars held a hidden secret? A secret not of little green men, but of a dynamic and surprising natural phenomenon. Join us as we delve into the mystery of the Martian spiders and discover the truth behind these fascinating seasonal features. Amidst the cold, thin atmosphere of Mars, an enigma stretches across the alien landscape, almost taunting us from millions of miles away. Known as the Martian spiders, these dendritic radial troughs in the region dubbed Inca City are not the work of extraterrestrial arachnids, but highlight the profoundly unique Martian climate and geological activities. It's a phenomenon absent on Earth, presenting a puzzle that combines elements of geology, meteorology, and planetary science in a way that captivates scientists and spectators alike. As we peer at these intricate patterns through the eyes of orbiting satellites, they whisper secrets of the Martian past and perhaps clues to its future. Martian spiders, scientifically known as Araneiform terrain, encompass the star-like fissures seen predominantly in the planet's south polar regions. Unlike anything encountered on Earth, these features develop through processes tightly coupled with the peculiarities of Martian climate. Specifically, the seasonal deposition and sublimation of carbon dioxide ice. As winter casts a frigid blanket over the polar landscapes, a layer of CO2 ice conceals the surface. And during the spring, as the sun returns, sublime dramas unfold underneath this icy veneer. Punctuated by the contrasting red dust and stark white ice, these formations begin their life cycle when sunlight penetrates the translucent ice, heating the ground beneath it. The trapped carbon dioxide, turning from solid to gas, builds pressure until it bursts through the ice in a spectacle of Martian jet geysers, scattering dust and vapor. This cyclical process gradually carves the sprawling, dendritic channels over millennia, sculpting the peculiar Araneiform appearance that mystifies onlookers.
Experts like Dr. Candice Hansen from the Planetary Science Institute suggest that understanding these processes not only unveils aspects of Mars' current climate, but also provides hints about historical shifts in its environmental conditions. Studying Araneiform terrain is studying Martian weather in action, Hansen remarks, suggesting a dynamic connection between surface features and atmospheric phenomena. Inca City, a sector within Mars's south pole, stands out not only for its spider formations, but also for its complex geological makeup. While its name might evoke images of ancient earthly civilizations, this Martian region is far from habitable, shaped by forces quite alien to our common understanding. What adds to its intrigue is the suggestion that these spiders could provide insights into past Martian climates, including the possibility of water ice beneath the surface, which has profound implications for theories about life on Mars. What is evident from orbit is that Inca City is not a city at all, but rather an intricately layered deposit possibly formed through successive volcanic activities, mixed with dust and ice accumulation over eons. This layering offers a record akin to geological sedimentation on Earth, but shaped by Martian specificities, mainly its atmosphere and temperature swings.
Imaging spectrometers and radar data from missions like the Mars Reconnaissance Orbiter have shown that beneath the CO2 layer, there might be stratified water ice dating back thousands of years. Researchers believe that the unique thermal inertia observed in the Inca City region could point towards interactions between the surface and subsurface ices and the atmosphere. This relationship can potentially mimic a climatic record, much like rings of a tree tell the story of its growth conditions year by year. As Michael Mellon, a researcher involved in the MRO's missions, points out, these ice layers appear to preserve a record of climate changes on Mars, much like ice cores do on Earth. Hence, Martian spiders are not just curiosities. They're clues in deciphering the planet's climatic history, thereby enriching our understanding of whether conditions might once have been favorable for life.
Our solar system is full of strange and unexpected phenomena. Here are a few bizarre occurrences on other planets that rival the Martian spider vents. Venus's upside-down rotation. Venus spins in the opposite direction of most planets in our solar system, meaning the sun rises in the west and sets in the east. This slow, backward rotation creates a day on Venus that's longer than its year. Uranus's tidal axis. Uranus is a giant gas planet tilted on its side by nearly 90 degrees, making it appear to roll on its side around the sun. This extreme tilt causes its seasons to be extreme as well, with each pole experiencing decades of sunlight, followed by decades of darkness. Jupiter's Great Red Spot. This swirling storm on Jupiter is a monster. It's been observed for centuries and is bigger than Earth. The exact cause of this persistent storm remains a mystery, but it's thought to be fueled by the planet's powerful internal heat. Saturn's hexagonal storm. At Saturn's North Pole lies a bizarre, six-sided jet stream unlike anything found on Earth. This persistent hexagon is hundreds of kilometers wide and spins at incredibly fast speeds. Scientists are still working out the exact cause of this fascinating geometric weather pattern. Neptune's dark spot. Similar to Jupiter's Great Red Spot, Neptune has a giant dark storm system, nicknamed the Great Dark Spot. This anticyclonic storm appears dark because it's colder and higher in altitude than the surrounding clouds. These are just a few examples of the weird and wonderful things happening on our neighboring planets. As we continue to explore our solar system, we're bound to discover even more bizarre and fascinating phenomena.
Let's summarize what we saw on Mars. In a landscape as alien and desolate as Mars, these spiders offer a reminder of the planet's dynamic and ever-changing environment. Each spring, as the Martian ice crackles and gives way to erupting plumes of CO2, we catch glimpses of processes that, while starkly different, remind us of Earth's own seasonal rebirths. The Martian spiders, eerie yet fascinating, serve not only as subjects of scientific inquiry, but as symbols of ongoing exploration, capturing our collective imagination and propelling our understanding of the Martian environment to new heights. Thanks for joining Sci-Sips on this wild ride to Mars. Before you blast off to your next adventure, hit that like button to let us know you enjoyed learning about the truth behind the Martian spider invasion. And if you're thirsty for more mind-blowing science, be sure to subscribe for a weekly dose of spacey exploration and earthly discoveries.